In this video lesson we're going to continue with the topic of Trigonometry C, and we're going to look at sketching graphs of wave functions. Now, we've already done all of the prerequisite work for this, so we should have enough knowledge to go straight on with an example here in order to sketch the graph of wave functions. So we want to sketch the graph of y equals sine x plus root 3 cos x for x lying between 0 and 360 degrees. So our solution then, we can basically choose which form that we want to put this into for one single trigonometric function. So I have chosen k times sine of x plus alpha, but you could have the x minus alpha, or you could have k cos of x plus or minus alpha. It's entirely up to you, and at the end of the day you will get the same graph out, and you should have seen that from previous video lessons that it will give you the same graph. So like I said, I've chosen k sine of x plus alpha because it's not specified. I've just chosen that, and that will give me k times sine x times cos alpha plus k times cos x times sine alpha. Now, equating coefficients to get my simultaneous equations, I can obtain that k times cos of alpha is equal to 1 and k times sine of alpha is equal to root 3. Now, solving for k, I need to square each of these equations and then add them. So that will give me k squared sine squared of alpha plus k squared times cos squared of alpha is equal to 3 plus 1. On the left hand side I've got a common factor of k squared, and I can evaluate that sum on the right hand side. My sine squared alpha plus cos squared alpha is equal to 1, remember, so I can conclude there that k squared is equal to 4, and therefore k is equal to 2. Now I can solve for alpha. So k sine of alpha over k cos of alpha is equal to root 3 over 1. My k's will simplify to 1, and sine alpha over cos alpha is equal to tan alpha. So tan alpha is equal to root 3. And I need to know which quadrant my angle is coming from, alpha. So I can use my cast diagram. If I look at my equation involving sine, I can see it's positive. So the answer there would come from the first or second quadrant. And if I look at my equation involving cos, it's also positive. It will come from the first and the fourth quadrant. So you can see there that my answer will come from the first quadrant. So alpha is inverse tan of root 3, which you should know is an exact value, and that is 60 degrees. Okay, so alpha is equal to 60 degrees. So we can now express y equals sine x plus root 3 cos x in the form y equals k times sine of x plus alpha, and that is y equals 2 times sine of x plus 60. So I now have all of the information that I need to be able to draw the graph. So if I firstly start off by looking at the points that would be significant So I now have all the information that I need in order to draw the graph. So I'm going to treat this like graph transformations. I'm firstly going to look at the graph of y equals sine x, then y equals sine of x plus 60, and then y equals 2 sine of x plus 60. So looking at the significant points on the graph of y equals sine x, I would have these points: 0, 0, 90, 1, 180, 0, 270, negative 1, and 360, 0. So you can see I've got roots at 0, 0, 180, 0, and 360, 0. I have a maximum turning point at 91 and a minimum turning point at 270, negative 1. Now, on the graph of sine of x plus 60, I need to subtract 60 degrees from all of my x ordinates. So that will give me negative 60, 0, 30, 1, 120, 0, and 210, negative 1, and 300, 0. And finally, I need to multiply my y ordinates by 2. So it will be negative 60, 0, 30, 2, 120, 0, 210, negative 2, and 300, 0. Now you can see in the question it asked me to sketch the graph between 0 and 360 degrees, so hopefully you can see that the negative 60, 0 is out with our range that we want to be using. So that then allows me to sketch the graph. So I can plot these points which are significant. And then draw the graph of y equals 2 sine of x plus 60, and then ensure that I label my points as well. So just now it would be a good time, folks, to pause the video before the screen goes blank, copy this down in your notes, and then complete the assigned exercise for today.